Now, and to keep us awake until the coffee break, Wouter van der Bund from the Joint Research Center of the European Commission. You're going to talk about hydropower and the EU policy on water management, biodiversity, and climate adaptation.
Okay, thank you, Anders. Yeah. So I'm really glad to be here at this conference on sustainable hydropower. Thank you very much for the organizers to invite me. So I'm working for the European Commission, where we have a research sort of facility, and so what I'm going to do here is I'm going to go a little bit into the EU policies that are especially linked with the environmental aspects of hydropower. So just to start, it's clear that hydropower has sort of really increased in the last century, hugely all over the world, and it has really become a very important source of energy. And now with the renewable energy policies, it really becomes a very sort of important part of the energy mix. And of course, it's not really uncontroversial, so to say. On the one hand, hydropower is really something we need for sustainable energy, and on the other hand, there's lots of environmental impacts, and these are just some press clippings on the effects of hydropower on the Danube and on sort of small hydropower that is really going to be it's going to have very many impacts on it. So in both of these sort of sides of the story are of course legitimate. So we really have to try to balance these things. So if you look at it at a global level, this is just an analysis of to which degree the hydropower has sort of reached its maximum potential globally, and it's just to show that in some parts of the world we really there's not much room to develop more hydropower, but on the other parts of the world, especially in the developing world, hydropower, there's really a lot of potential to develop hydropower and an opportunity to develop hydropower in a sustainable way. And the previous presentation is really sort of was emphasizing that. So hydropower is really at the heart of the water energy nexus, and it's linked to energy policy. I'm not going to go into that too much. Climate change adaptation policy, water resources management policy, and biodiversity policy. And it's really about the need to achieve synergies and compromise solutions. And so what I'm going to talk a bit now is the EU policy framework that we have in place that I think recognizes this reality, but it's also rather complicated and difficult to implement. So the Green Deal is sort of in the European Commission now recently the big policy framework that we have that's really putting sustainability at the center. And that includes renewable energy on the one hand, and nature conservation and on the other hand that are really important aspects of that. So what I'm going to go through now mainly is on the Water Framework Directive and hydropower. It was already mentioned several times by previous speakers, and especially the concept of ecological potential that is really key in balancing the needs for society of hydropower in this case, and the environmental optimization of that. And also exemptions is very important aspect of that. Then I will talk a bit about biodiversity policies in hydropower, especially the free-flowing rivers. And then the EU taxonomy in hydropower. And in the end, I think it's really about showing that this is a quite coherent framework that we have in place in Europe for hydropower and environment. So Water Framework Directive, just in a nutshell, it's a policy framework we have in place in Europe, established in 2000, that's protecting all surface waters and all groundwaters, and it includes transitional coastal waters, lakes, and rivers. And the objectives are to reach a good ecological status, or a good ecological potential, I'll go into that later, by 2015. So it's already a while ago, with the possibility to extend it to 2027. So reaching the objective is an important part of it, but also, I think equally important, non-deterioration. So it's not allowed to go down on the quality gradient, so to say, in principle. And it's really important aspect of the water framework directive that it's about water management at the catchment scale, river basin scale. And member states, member countries are obliged to make plannings at the scale of the catchments. If they are transboundary catchments, they have to plan in an international way. And this sort of should ensure that all the sort of the skills, the relevant skills are addressed. Just a note here about Norway, because we're in Norway here. Norway is not an EU country, but it is implementing the Water Framework Directive through the EEA agreement. The only difference between the EU countries and Norway is that they are 6 years behind in their deadlines, which is a good opportunity for Norway to learn from the experience of the other countries, of course, and to implement better than everyone else. So good ecological status, it's a measure of ecosystem health, ecosystem functioning and structure. And it's assessed using biological indicators like fish and benthic fauna, macrophytes, and benthic flora like diatoms. And the idea is that these are holistic indicators that say something about ecological health in general. And the idea is that for good status, the situation should be close to undisturbed conditions, close to reference conditions. So you have reference conditions that are the undisturbed conditions, and then the quality classes are measures of deviation from the reference conditions, and then there is a line between good and moderate, and this is what has to be achieved. And then, of course, there is the non-deterioration across this gradient. Now, the Water Framework Directive, I think, is one of the interesting and good things about it is that it recognizes that it's not always possible to reach good status because we have sustainable human activities that we rely on society. And one of them, of course, is that we have to do flood protection, we have hydropower, we have navigation and things like that. So we cannot leave our rivers natural, we have to alter them physically. In a case like that, it's recognized that you cannot reach the good status, and that's okay, because and then there is a good ecological potential as an alternative objective there that is about maximizing the ecological conditions given the constraints of the use. And this category of water is called heavily modified water bodies. If you have hydropower in a river system, this is something that I think should be used because you really are changing the water bodies considerably, and good status can often not be reached. So there are strict conditions, strict rules for designating heavily modified water bodies. So one is that you have a sustainable development activity that causes a change in the character, on the physical character of the river or the lake. And it's not possible to reach good status without having a significant adverse effect on the use. So if it's possible to reach the use by mitigating it, then it should not be heavily modified. But if it's not possible to do that, then it can be heavily modified. And then also very important is that the beneficial objectives cannot be reached by other means which are a better environmental option for a reason of disproportionate cost or technical feasibility. For hydropower, this is really important because you really have to consider the energy mix there, and also what you need to consider there is sort of the changing role of hydropower now in the energy mix that we see now. That it's more for regulatory power, so this is the use that we need, and that needs to be considered. So so the best environmental option for energy provision is really about to consider the impacts of different renewable energy options and also of planning hydropower, minimizing the impacts. And these are some examples from the Mekong on the left, where it showed that it's really possible by properly planning the hydropower development to really sort of optimize the impact on the sediment flow. On the right hand, there is a recent paper by Carolli that came out that is about the Balkan, that shows that in the Balkan that it really is possible to plan hydropower in such a way that you minimize the impact and keep much of the existing free-flowing rivers intact with having quite a lot of hydropower production. And so for heavily modified water bodies then, there is a reduced objective. It's called ecological potential. So the idea is, it's a bit of a complicated picture, is that the blue arrow on the left is showing sort of the effect of your hydropower dam, for instance. You have the present ecological conditions, and then you have to see what is possible to mitigate without a significant adverse impact on the use, the second blue arrow. And this sort of defines the maximum potential that you can reach. And then the actual environmental objective, the good potential, is a deviation from that, a slight deviation from that. So you have to take into account all possible measures, minus the measures with a small ecological effect. And what's important here is it's not about cost here at this stage. You have to consider measures even if they are expensive. And so, yeah. And then this is a really complicated picture because we try to make a practical guide for countries how to implement these very complicated requirements. And of course, I'm not going to explain this whole picture, but the important part here is that you have the mitigation measures that play the key role in this on the right side. And then you have to understand how the mitigation measures in fact affect the hydromorphological conditions and how the hydromorphological conditions affect the biological conditions, so the fish and not only the fish. And so it's really important that you understand the measures you can take and the biological effect in the end that this will have. And this framework needs to be implemented sort of throughout. So the key steps in ecological potential are identification of the mitigation measures. And this is really the big theme of this conference. So I think this is really very important. Excluding those that have a significant adverse impact on the use. To ensure ecological continuum, also very important. And then to identify the hymo conditions and the biological conditions that are sort of consistent with this mitigation. And then you can identify the measures you need to take to reach the good ecological potential in the end. So we made a guidance document a couple of years ago together with the member countries to really sort of try to have a common understanding of how this should work in practice. And then we asked the member countries which of these steps they have implemented partly or fully. And this is just the outcome of this so-called intercomparison. And then you see that there are still quite a lot of problematic steps there. And the ones that are the key issues, I think, is how to define, how to quantify significant adverse impact on the use, because this is really key in which mitigation measures you should consider.